Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning. My name is Lee Derricks. I'm the Director for Education and Scholarly Communication at Microsoft Corporation, and I'd like to welcome you to the Data Models and Preservation session. This is a 2-hour session with 4 presentations, so 30 minutes each. I'm going to ask the speakers to try and keep it to about 25 minutes, so we'll have enough time for questions. If we kind of save up enough time over the course of the whole time, maybe we could save some time for kind of broad questions over all the presentations at the very end. The first speaker is Carl Lugosi, who will be presenting about a web-based resource model for eScience, object reuse and exchange. So I'll hand it over to you, Carl.
Thanks, Lee. Actually, the first speakers are Simeon Warner and Carl Lugosi. So Simeon and I are going to be splitting this up. And without further ado, I'll go on. Thanks for coming to lovely Indianapolis. I want to start off very quickly to say that this is joint work. Simeon and I are just representing a group of the main people involved in this work are the people you see up there, and it's really a cast of thousands. A whole bunch of people who have been involved in this, a technical committee, liaisons from various other interested parties. So there's a whole bunch of us. So the 2 talking heads here did work, but they're just one of many heads. And of course, one has to pay homage to the reaper or the payer. And I want to thank especially Microsoft, who's put a lot of trust and effort into this, a lot of cooperation. So without further ado, we'll get on to content. So the subject that we're discussing here is the notion of an aggregation. And what I want to argue to you is that this notion is something that we work with every day in our real life and in the web context. And what our work is about is to be able to identify and describe aggregations of web resources. So we're going to build up to that point. Simeon is going to describe a data model about how we do that, and I'm going to give you some motivation. So to get the ball rolling here, it's always good to look upward and recognize the fact that human beings have been aggregating objects into meaningful semantic clumps for as long as we've been looking up into the sky. So as we all know in the modern age, that they are just stars up there that are separated by vast amounts of light years. But human beings seem to have this penchant over the ages to want to be able to take those things and clump them together and call them something and give them an identity. So we've done that with constellations, and we do that every day. And to move on to the subject of this workshop, eScience, we've been trying to put knowledge together in clumps ever since we put knowledge on pieces of rock. This picture here is a very early aggregation, but at that point, at that time, it was possible to convey it on a single medium. This, by the way, is the Babylonian astronomical catalog. You might be interested in looking that up if you want to. So quickly, the limitations of that medium the limitations of putting things in one spot became obvious. This is an 1857 astrophysics paper, and you'll notice that the paper includes text, and it also includes a set of data. And as we increasingly recognize in our science publications, those data tables are a horribly low bandwidth reduced version of the stuff we really want to work with, the data. So one of the core problems here is how do we make multimedia type of objects bound together with other objects and call them a thing? That 1857 paper, the limitations seem to live on. This is a Journal of the American Chemical Society paper, I think a very recent one. I pulled it off the JAX page just recently. And once again, we see this very poor reduction of data and a picture, and we sort of reduce them down to this textual format, or we put them on paper on something static called PDF, and we can't do much with them because we want to contain them in one physical entity. So over time, we see these aggregations develop, and we see other ways of dealing with the problem of, I have this thing and that thing, and they're really one thing. Here's a version of a paper with the photographic plate from the astrophysics paper kept separately. So we can sort of semantically say these things are a whole, but the actual management of making them a thing was done sort of out of band. They're breaking the doors down. So the famous man in the gorilla suit is going to walk in, and we're going to see if you all notice the man in the gorilla suit in the middle of the talk. So the argument here is that, especially as we move into this realm of what we're discussing here, eScience, we're dealing with objects that are naturally compound. So here is a 2006 astrophysics paper, and you'll notice that it's discussing this I believe it's a galaxy A1795. I'm not an astrophysicist, I'm not an astronomer, but I believe that's what it is. And all of these other objects stored at different places. This is stored in Spain, this is stored in Cambridge, in Maryland, in Strasbourg. These all are part of the scholarly object, but the binding is done in a sort of manual or ad hoc manner. There might be a linkage somewhere in it to something else, but there's no way of defining this thing that we call that scholarly object. So to step into a sort of what I'll call mundane without insulting Simeon, who works on the archive, real example of what's going on here. This is a splash page from the physics archive, or the archive. I don't think I should call it the physics archive. And if we take a look at this splash page, we intuitively, as human beings, look at it and say, aha, I understand. That is the paper. That is a human visible version of sort of this combination of the things we call the paper. But if we look at that page, we notice that it has a URL, okay? Upper left-hand corner, there is a URL of the splash page, which if you're a semantic web type, you'll be careful to say, that is not really the identity of the paper. That is the identity of this funny little HTML page that describes the paper. And then if we look over on the right here, we'll notice that the paper is available in multiple formats, each one of which has a URL, right? So each one of those is also some part of the paper, some aspect of the paper, but their identity is also not of the paper. And then if we even go further down, we'll notice that there are versions. We'll notice that there are other identifiers of this thing. There's relationships to other objects. So the lesson here is, even if we go to something as popular and as in current existence as the archive, we'll see that the objects we talk about are these combinations of things that we don't have an identity for, and we don't have a machine-readable way of describing them. We have a human intuitive way. I can look at that, and with my advanced brain, I can say, aha, that clump of things is the paper. But if we're starting to deal with crawlers and machine agents, we have no way of looking at that and saying, that's the paper, that's the aggregation, that's the scholarly object. So that's the issue we're dealing with here. And just to convince you that this is not only a problem in eScience, it is a problem in the general web space. If we take a look at Flickr here, we'll notice that there's a notion of a thing called a Flickr set. A Flickr set is a group of pictures. There is no real identity for the Flickr set. And there's no real description of it other than this sort of human readable description. And there, again, is a URL of it, but it's the URL of this HTML page. It's not the URL of the Flickr set. And even if we go down to the granularity of a Flickr picture, that picture is available in thumbnails, in high resolution, et cetera, et cetera. So again, we have an object that's really a composite of a bunch of objects, and we have no way of talking about the thing or describing it. So that's the problem. The problem is trying to come up with a way of describing these things and giving them an identity, and giving them that identity within the web. So there's been a lot of, I come out of the digital library community, and other people come out of the grid community. And one of the criticisms of these two communities, and I'll criticize myself, is we did a lot of work which didn't integrate well with the web. So we had this funny parallel play world where we had the web folks who were doing a bunch of things, and we had the digital library folks who were doing a bunch of things. And things like crawlers didn't seem to notice what was going on in the digital library world because they couldn't reach into that funny ad hoc idiocentric space. So when we started this work, we said we must work within the constraints of the web, within what the web defines for us. And that allows us to integrate with existing web applications such as crawlers. It gives us a potential for adoption by other communities outside of the eScience community, like Flickr. It allows us to give the potential of general tools. And last of all, that last bullet up there, it incorporates the social web. It allows us to take eScience and put us into this funny world of Facebook, MySpace, et cetera, blogs that is increasingly interesting, and we want to work in the eScience type world. So the foundations, to quickly review the foundations here, the foundations are this web architecture, some of the stuff that's come out of the semantic web world, such as RDF, linked data, which is a recent place of interest by the semantic web folks, and then the notion of cool URIs. And I'll let you look those things up on your own. To quickly review what the web architecture gives us, the web architecture gives us very, very little. It gives us the notion of URIs that identify resources. It gives us the notion of content negotiation, and gives us the notion of representations. This is the entire web architecture. That's all it gives us. So that we don't, you'll notice when I look at that, there's nothing about an aggregation, for example. The semantic web, on the other hand, gives us a little more. It gives us the notion of URIs again, but this notion of RDF and vocabulary. So RDF to describe relationships between things, and vocabularies to give URIs, to give identities to those types of relationships. And lastly, the linked data world gives us this notion of URIs for things rather than just web pages. So there's this distinction that's increasingly being made between the document-centric web of the 90s and the data-centric web of the 21st century. So we tend to relate and we say, oh, a URI, that's of a web page. And the world of the linked data folks is that a URI is an identity of a thing in web space. So that's appropriate as we move into the data model, and we're going to get there in a second. So where we are so far is the subject of our work is aggregations of web resources. And our approach is to create two entities in the web world. We're going to instantiate the notion of an aggregation, which is going to be a web resource. It's going to have a URI. And then we're going to also have something called a resource map that is also a thing that describes an aggregation. So there's the aggregation and the thing that describes the aggregation, and they each have URIs. So let's put this now in the web context and quickly take a look at a picture of this, and then Simeon will jump in here. Here's the web if you don't recognize it. It's a little bit reduced, but so the web gives us these resources that are linked together. If we take a look at that and we say we want to draw a boundary, we want to say, well, there's this arbitrary subgraph. There's the archive page, for example, and we want to say that is a resource. So there's no way in existing web architecture and web terms to draw that boundary and say what's in it. We don't have the capability to do that. So what Simeon's going to show you is what we do is we instantiate another resource called a resource map, which emits a document, a machine-readable document in RDF or in Atom that describes an aggregation. And there's the aggregation. That other node there is a new resource called an aggregation that is the lasso around those objects that is described by this resource map. And then what happens then is that other resources can refer, they can link to those resources, and those aggregations and resource maps become part of the general web. So what we've accomplished in this, Simeon, what we've accomplished in this is we have created a way to describe and instantiate and identify these aggregations, which we say are part of the web of science.
Okay. Thank you, Carl. So I realize as I'm sitting here listening to Carl that the way I'm going to talk about this is in part a reaction to a few comments we've had recently saying that, oh, you've got this thing called a data model, we're really a bit scared of that. And I'm going to put it one way and argue that we want to have our cake and eat it too. At one level, what we've done is we've built something that's really simple. You can just read how to do it, write an Atom resource map or whatever. But we didn't want to just do that. What we wanted to do was craft something which had some sort of sensibly defined semantics underneath it. And the argument for doing this is that you separate the notions of design from implementation. We can have several different serializations, for example, yet they all conform to the same sort of model and design. And secondly, in a way, abstracting the data model provides us with some sort of future-proofing. Although it seems hard to imagine today, HTTP will probably go away at some stage. It wasn't here that long ago, was it? So we sort of separate out these concepts. The data model really introduces two things. Carl's already talked about this a little bit. The central notion of the ORE work is the notion of an aggregation. What we have here, this node labeled A1, and we're saying A1 is an aggregation which aggregates three things. The three things we call aggregated resources, sort of sounds like English, and they're related with this relation RE aggregates. And that's defined in our vocabulary, so we sort of added that term to the semantic world. The second thing is, as Carl already mentioned, now we've got this aggregation, we're not going to confuse the aggregation with the document that describes the aggregation, so we introduce that separately with a different identity. We call that a resource map. We say the resource map describes, there's its representation, and I'm thinking there's a line. Okay, the resource map describes the aggregation, and one can infer then also that the aggregation is described by the resource map. Throughout the documentation, in spite of my comment that HTTP URIs may not live forever, they really are the foundation of the current web. And we wanted to make this stuff very usable. We wanted to give aggregations an identity that you could do something with. One of the criticisms that's been leveled against various directions of the digital library community in recent years is we've invented all these other URI schemes that you have to know how to go and do something with it. Basically, every piece of software on your computer knows what to do with an HTTP URI. You know, you paste it, you cut it, you grab something, and you get something back. So we've recommended throughout the documentation that you use protocol-based URLs like HTTP. And what that allows us to do is say, we want to talk about this aggregation. We don't want to talk about the document that describes it. We want to talk about the aggregation, Carl's paper. And I want to be able to give you the name of Carl's paper, this URI. But having given you this name of an abstract thing, you then want to be able to get the real description. So we've used techniques from the linked data world that allow your web browser to go and request that and get back another document that describes it, this resource map. In fact, you can then use other parts of the web architecture to get back a resource map in a format that's preferred to you. And we have a few sort of simple rules about how to do that in a way that makes sense. This also allows us to piggyback on the notion of authority within the web. There's some sort of pretty simple concepts here that if you start off at some place on the web and you get taken somewhere, you have a sort of chain of authority linking these things together. So what we can say is that if I have a description, Carl's paper, which has an identity, and I try to access that URI, and I get given a resource map back by it, then we call that an authoritative resource map because it was linked from the original identity. We have a couple of rules about how, if there are ones in different formats, they should all be equivalent in some straightforward ways. And then you have the notion of, well, there can be other ones. You know, I like to say that in this world, anyone can say anything about anything. It's just you have to decide whether you want to believe it. I think I have a picture that demonstrates this a little better. So here we have our aggregation. We have one resource map on the left describing it. And perhaps we want to add a couple of others in different formats. Not quite sure we want all three, but we want to be maximally interoperable. So we have three resource maps. If they're all linked to A1 with these relations served from A1, then these are all authoritative. We can trust these by the simple mechanism of understanding where we got them from. But anyone else can create a document, a resource map that says, oh, I describe A1 as well. But if there's no way to get from A1 out to those, then those are just somebody else's description. And in general, we would discourage this practice, but we're sort of, thinking through it, we realize that it is possible and it will happen, and you have to specify what people should do. an alternative, instead of saying that these new resource maps describe exactly the same thing, would be to create a new aggregation node in a namespace that's authoritative for the other resource maps and have them describe the same constituents perhaps, and then that would be authoritative in some other sense. And that's the data model pretty much. I just described to you that top line of three things. We have the central concept in aggregation, which aggregates one or more aggregated resources and is described by one or more resource maps. There's a little blip at the bottom with this notion of proxies, which I'm going to talk about in just a second, but that's pretty much it. The beauty of this is that what we've described is, of course, our little component in this RDF world. So you can use all the rest as well. We have a couple of specific vocabulary terms to help with issues in our domain. So one of the things we keep talking about, because we come from the scholarly communication domain, is the notion of publications. A lot of those have other identifiers like DOIs. So you don't want to make a mistake like try and say the DOI, oh, that's now the aggregation, because that existed before, it has other sorts of semantics. But what you can do is then link it up with your aggregation, say it's similar to in some sense. And we can add any other properties we need to these objects because they exist in this world. So we can have a whole bunch of metadata about our resource map, who made the resource map, when it was made, when it was updated, all that sort of thing. And metadata about the aggregations. And we, of course, didn't need to add our own special terms for all of this. We've just adopted the more common terms from other vocabularies. We have a couple of things which we say are required just because they're kind of necessary to make things work nicely. We need some sort of notion of authority and some sort of update date, which you can think of as just like the minimal things your file system offers you to be able to do useful things like back it up or copy it. Between all these resources, we can assert essentially arbitrary relations. So perhaps here I'm typing my aggregation. It's a journal comprised of articles, has another version, and there's my set of aggregated resources, and those are articles with a different typing. And we didn't specify our own vocabulary for doing these things. We don't place any limits really on what you can say. But while thinking through this, we did notice one distinct limitation. If I make the two statements, Carl is a man and Carl is visiting Indianapolis, Carl is a man is probably going to be true for the entirety of his life. Carl is visiting Indianapolis is extraordinarily unlikely to be true even for the rest of his life, and certainly wasn't true a couple of days ago. In the sort of RDF world, if Carl is this identified object and we make these two statements, the sort of usual way of combining data is essentially you're doing this sort of connection on same URIs. So if you start connecting Carl is visiting Indianapolis with the previous version of this slide, which says Carl's visiting Philadelphia or Pittsburgh, you start ending up with some sort of weird contradictions. So what we need is a way to say Carl is visiting Indianapolis in some context, the Microsoft eScience thing. So what we've done here is introduce this notion of a proxy URI, which exists within the context of an aggregation. So this is just an example here. So it's a very simple aggregation with A1 in the middle. It aggregates two things, AR1 and AR2. And AR1 is page 2 of a paper, and AR1 is page 1 of a paper. And this aggregation represents the first 2 pages of the paper in reverse order. It wouldn't make much sense for me to say page 2 has next page 1, and sort of think of that in a global sense. So what I want to be able to say is page 2 has next page 1 in the sense of this aggregation. Yes, I think we're almost done, aren't we? Oh, yeah. So I introduce here these blue nodes, the proxies, which stand for the resource, the aggregated resource in the context of the resource map, and then I can sort of localize these statements. Another step of that, something obviously very important in the scholarly domain, is to be able to express where something came from. So if I have these grayed out resource map on the top and something in the bottom, I want to say that the aggregated resource, which is actually the same thing, came from one place to the other. I obviously can't say anything useful by making a statement that just arcs around from AL1 to AL1, but by using the proxies, I can say that this resource in this context came from that place. So what do you do with it? I happen to work with the archive, ePrint archive. How might I use this? And we haven't actually done this yet because we've been busy writing the specs, but we're sort of thinking about this. What's useful to express for someone else to be able to understand in a machine-readable way? I can express perhaps the structure. We divide it into archive subcategories, articles. They're all very obviously aggregations. Carl already mentioned the notion of versioning. We have a concept of an article, which comprises a whole bunch of different versions. What about articles by Joe Smith? That's a set of articles, but like a result set, but it fits this simple notion of an aggregation. Constituents, Carl already mentioned. And perhaps all the internal and external components. One of the beauties of course, grounding this, where everything is just out there on the web, they don't actually have to be all in my repository. And I think that's pretty much general in the eScience context. And I think now, I'll skip that one in the interest of brevity.
So to quickly close, I want to mention one other project that is going to deploy this and explore this in quite a bit of depth, and then talk about one example of how it's used. So a number of people here have heard of OREChem since they're involved in the project. OREChem is a project that's just starting in January, that's funded by Microsoft, that is exploring how to use ORE as the basis of what we'll call e-chemistry. So if you think of chemistry as based around the notion of a molecule and its relationships, people who work on experiments in that area, people who have written papers in that, all sorts of properties of that, what we're going to do is explore how to use ORE as the basis of that. And the people here involved in it, you can talk to them later. There's Peter Murray Russ, there's Jeremy Frey sitting over there, there's Simon Coles, lots of people. So, and Jane Hunter. Jane, I saved you for last, because one of the things we're really interested in the project is the notion of of authoring these objects. So here you are, you're in a modern eScience type of environment. You want to build a publication or a result set, which is a combination of lots of things pulled in from lots of different areas. Jane has done some really nice work on something called the scope architecture, which is an authoring environment that spits out these compound objects and then stores them in repositories. So and the repositories are things like Fedora or DSpace or things like that. So that's where we're headed. I appreciate your time, I appreciate your attention, and I'll turn it back to Lee.
I think what we could do is maybe take one question, allow all of these computers.
That for a second, okay. Any questions?
Other questions?
Yes.
Can I use the microphone? Oh, okay.
You're good.
No, I don't know whether this will be safe or not. When you said you may have multiple maps for different sorts of serializations, what if I have different maps because I want to use the aggregation differently?
So the aggregation is a single URI. You can use it differently. You can point to it from lots of different different contexts. The reason we have different maps is actually we support different formats. We support Atom, we support RDF XML, and we support a couple of others. But that's the reason for the different maps. Okay? Okay, thank you.